Hello, we are going to walk through some of these fixtures to see how to fixate these parts in order to do the appropriate value-added processes to them. So the first part here is going to be the sphere, and we needed to drill a center hole into it. As you can see here, this is my sphere within the fixture, and since it is a sphere and there was no specifications on anywhere direction wise on the sphere except it had to be in the center. It can be dropped in or rolled in, however which way to do it. I took considerations on quite a few degrees of freedom here. You can see that this whole piece is solid. Whole piece is solid, so the ball drops, or the sphere drops in there. It's got this back support, which helps the counteract the force between the drill bit coming in right here. This helps center the drill bit and make sure that it's coming in nice and straight. It doesn't go through any crookedness. The high ridges here counteract any rolling. Inside the fixture would be a high friction material, so the ball or sphere did not roll, and it allows for easy access and prevents it from rolling, prevents it from moving, and it should be nice and secure for the sphere to get its drill through. And yeah, there we go. On to the next part. Here we have the next fixture. We had this sort of top hat looking thing, and we wanted to drill this central hole through it. That would be the first thing to do. So this fixture is this guy right here. This whole thing, spherical thing. As you can see inside, the center part of the piece drops in, fits very snugly, allows it to stay put. And then I've got these tabs here with bolts fixating it. These tabs help index correctly, as well as fixture the part to the fixture itself. Holds it down, so when the drill press goes down, it does not move, and it will hold it down when the drill bit comes back up. Now the next part would be the groove, and once again we're trying to counteract the rotational forces here. That's another benefit to these tabs. It counteracts any rotational force, allowing the part to be machined with this groove here without moving, twisting, or turning. And it's pretty solid. So let's move on to the third part. Here is the third part. We have triangle stock that we are slicing, not really in half, but we're slicing lengthwise into the stock with this. So here I have a small part of the fixture, however long the triangle stock is, fits the triangle stock perfectly, slides right in. And as you can see on here, these surfaces are flat, which allows a blade to come very close to it and allows it to cut through horizontally like so, and will prevent it from moving, twisting, or turning, and to prevent it from going backwards, because the blade will be coming from this direction over here this way, from left to right. I've got a stop plate right here to counteract that force. And then that will allow the part to sit securely in place while it is being cut in half, or however, what is that, third, half, third, whichever. And the final part. So here we have a sheet of some material with these funky organic looking curves and pieces cut out of it. So here I made use of these temporary tabs that can be broken off in a later process. This helps index the part not only for securing it, but also indexes it for whichever process is going to be cutting out these pieces of metal, because it'll have to be in the same exact place on this sheet of metal. Therefore, we index them so they sit down and it will cut in the same spot every time. and we have a V channel here. This allows the metal shavings to come down and not get caught up in the part. As you can see, these are going to be bolts once more. Bolting this piece down to the fixture allows no, because of all these cuts and turns, there's a lot of directional forces. However, because of its bolting down in all four corners, there is no rotational force either clockwise or counterclockwise. It is bolted to the fixture, so no up or down motion, and because it is bolted, it will not move up when the burr, bit, or machine comes up from the finished part. And that would be it. Thanks you for watching.